All right, welcome. We are back on part 11, number 63. Going to work through probably 66 in this part. Right. So here you have to simplify rational expressions. And then there's, it says record your work on a separate piece of paper, but I spaced it out on this copy where that shouldn't be necessary. You should be able to do it all on the same piece of paper. So let's write the problem down. This problem set is all about factoring and canceling common factors. That's what this is all about. And I haven't worked these problems in a year, so we'll see how good they were when I made them. So you want to look at each section and see if they can be factored. And if you look, right, x plus 1 can't be factored. X plus 2 can't be factored. But the 2x squared minus 10 can be, and so can the 3x squared minus 15. So things to look for when factoring, right? Is it factorable using like a difference of squares, or like regular quadratic factoring, or maybe like slide and divide, or I mean, I won't give you guys like difference of cubes or sum of cubes or anything like that, but that could be the way they are, right? Like in an actual polynomial. So we want to factor this piece and this piece. So let's go ahead and do that. You can factor a 2 out of this term and this term, giving you x squared minus 5. I went with classic white here on this color. I've been changing it up just because I felt like it, but you know, we'll just keep it. So, and here we're going to factor a 3 out, because 3 goes into 3 and 3 goes into negative 15. So, this is the reason these factor out this way, in case you're confused on how I got the x squared plus 5 or x squared minus 5. If you were to redistribute this back in, you would get 2x squared minus, and then 2 times negative 5 here, which would be negative 10. So 2x squared minus 10, and that's exactly what you got here. Right? And it's the same over here. So now you just cancel out any common factors that are able to be canceled, right? And so that would be the 2x minus 5, or the x squared minus 5, and that's it. Now, one huge mistake I see students make all the time is they think that because they just see an individual term that's the same on the top and bottom, that they can just cancel them out. They think that, alright, whoops, I turned into a plus 2 somehow. They think that like you can just cancel an x out of here and just leave it with x up here. That is not the case. You can only cancel terms when you have products together, not sums or differences. If the term you are trying to cancel is being added or subtracted to anything, you cannot cancel it. So if you're thinking, I want to cancel just this x squared, well look, is the x squared being added or subtracted to anything? Well, it's being multiplied by the 2, so that's not a problem. Multiplying is fine. But adding and subtracting is the problem. So you're subtracting 10 right here. So you cannot cancel it. Just like you could not cancel this 10 if you felt the need to do that. Maybe this was a 10. You think, let's cancel the 10. So that's not possible. All right, it's not true. And then you're thinking, well, this is this x squared is being minus the 5, right? Well, why can I cancel that? Well, think of it this way. Think of this entire piece as one quantity, one thing. This whole group is being multiplied by the 2. So this is one of the pieces of the product, and this is another piece of that product. So if you could cancel all of it, you can, which you are allowed to do. So you cancel and cancel, and that's what ends up happening here. Now, this can't be simplified any further. If you wanted to really simplify your response, you would distribute the 2 in, and that would get you 2x plus 4 over x plus 1. I don't care if you do it this way. Leave it like this, or leave it like this. Something you don't want, though, that's the worst not equal to sign I've ever seen. Something you don't want, though, is 2x plus 2 over x plus 1. Right? You don't want that. That's not true. You'd have to distribute to both. All right, so there's your problem done. 64. This is a division problem. X squared plus 6x minus 7 over 3x squared divided by x plus 7 quantity over 6x. Now, the way I taught you guys how to do this, it's always think of when you're doing like division of rational expressions, convert it to a multiplication problem. So instead of dividing by this x plus 7 quantity over this 6x, instead multiply by its reciprocal. So you're going to take this and turn it into a multiply, and then flip this fraction. So you're going to get x squared plus 6x minus 7 over 3x squared times 6x over x plus 7. Now, in this case, you just want to factor and cancel and factor and cancel. The only piece that's immediately factorable is this top piece. Right? This is factorable. Thinking of two numbers that multiply to give you negative 9, add to give you positive 6. Well, never. I can't even read my own handwriting. It's negative 7 and positive 6, right? Yeah, or whatever. All right, so that would be a positive 7 and a negative 1. So you'd have x plus 7 and x minus 1. All right, so I'm going to go ahead and rewrite that down here. X plus 7, x minus 1, 3x squared, and 6x and x plus 7. Now, the reason why over here we can cancel across the product is because multiplying two fractions together, this fraction times this fraction, you just multiply straight across. So if you wanted to do it this way, you absolutely can. I've never been one to tell you how you do your math problems, so long as you do them. So I just mushed it all up into one fraction, and hopefully this will help you see the canceling better. So we've got 4 pieces of products up here. The 6 is being multiplied by the x, which is being multiplied by the entire x plus 7, which is being multiplied by the entire x minus 1. So there's 4 pieces of products. Now, if there was anything in common, if the factors up here, these 4 pieces, if any of these 4 pieces were also down here, you can cancel it. So this is one piece, this is another piece, and that is being multiplied by the x plus 7, so that's another piece. So if you look here, you can cancel out the x plus 7s. But that's not the only thing you cancel out. You can also reduce the 6 over the 3. So 6 over 3 is just 2 over 1, so you can reduce that to 2 over 1. And then x over x squared, imagine this is x times x, and this is just 1x. You can cancel one of these x's. So what you'll end up having is a 2, and then, alright, that became the 2. That got canceled. This got canceled. So you've got your x minus 1 over the 3 became a 1, so you don't need to write that. The x squared, one of the x's got canceled, so you still have 1x down here. And the x plus 7 got canceled. So that's it. You just have your, this is it. There's your problem. Let's go ahead and make a nice pretty box for it. Alright, so there's another problem down. Number 65. This brings us into a new category of problems. Perhaps the hardest type of problems that could exist for you guys is number 65. In my opinion, these types of problems contain the most challenging content. It's a lot of free thinking and a lot of chances to make math, like arithmetic mistakes. But I'll try to give them, I'll give you guys fairly straightforward or simple questions like this on the test. So here, you're subtracting fractions. And you can't just subtract any two fractions willy-nilly. You can only subtract fractions that have a common denominator. So you need to get a common denominator. And to get a common denominator, you have to look and see what your denominator pieces are currently. So right now, look at the pieces of the products. You've got a 7 and an x. Here you've got a 3 and an x. They both have an x, so that's something they have in common. But this one has a 7, and this one doesn't have a 7, and instead has a 3. So this is all about this is all about sharing. Sharing is caring with these fraction addition and subtraction. So you need to share the pieces that the other ones need. So this has a 7, this needs a 7. So you multiply by 7 over 7. And then on this other problem, this other fraction, it has a 3. Right? Like it's got the 3. This one doesn't, so it needs the 3. And now you multiply these together. So you've got 3 times negative 4, that's negative 12, over 3 times 7, that's 21x, minus 5 times 7, that's 35, over 3 times 7, that's 21x. And now when you share, now you have the common denominator. And so now you can subtract. So the way you subtract fractions, if you've forgotten, sort of shame on you actually, but you know, whatever, you're still here. So imagine you've got like 4/5. Actually, that's even a more complicated fraction than I want. How about 2/3 a cup of something, and you're taking away 1/3 a cup of it, right? Well, what do? 2/3 a cup minus 1/3 a cup. Hopefully your brain connects the dots that it's 1/3. And what happens is the denominator will stay the same. This stays the same. But you subtract across the numerator. And you subtract because of the subtraction sign. 2 minus 1. So that's what we're going to do here. You've got negative 12 minus 35. All over that common denominator. So negative 12 minus 35 is negative 47. And that's fine. Just leave it like that. Alright, that was not so bad. Number 66. This will be the last problem for this part. And it is more of a pain. 5 over x squared minus 16 minus 2 over 3x squared plus 12x. And I'm not saying these, you guys are taking the oral test right now in my classes as we're reviewing for this, and you guys are like, well, but you didn't say quantity. And I'm not saying it in a way that you need to write it. You clearly already see what the problem is, so I don't need to communicate it so accurately. Right, so the idea is factor and cancel. So we want to factor these two pieces. They're the only pieces that can be factored. And then cancel any wait, what am I thinking? We're not factoring and canceling. We do need to factor, though. We're subtracting fractions, so there's not going to be a canceling thing happening. But we do need to factor, so we're going to do that first. So x squared minus 16 is a difference of squares. That's x squared minus 4 squared. So that factors into x plus 4, minus more 4, right? And you could also think of this as x squared plus 0x minus 16. So what two numbers multiply to give you negative 16 and add to give you 0? Well, that'd be positive 4 and a negative 4. Right. Then the 3x squared plus 12x factors in by greatest common factor. The greatest number that goes into 3 and 12 is 3, and the greatest amount of x's that go into each of these is a single x. And then you'd have x plus 4 left over. And if you were to distribute n, you would see that that's what you'd get. Alright, so let's rewrite this problem with this factored stuff. 5 over x plus 4 times x minus 4 minus 2 over 3x times x plus 4. Now, the reason we want to factor first is because up here I was talking about like sharing pieces that they don't have in common. Your first thought might have been to share all of this with this one over here. But that's not necessary. Once you factor, you can see that they actually already have something in common. They both have an x plus 4. See? X plus 4. So the left one has got this x minus 4. The right one doesn't, so you need to give it an x minus 4. Now on the right side has got a 3x. The left side will need that 3x. Alright, so now you multiply across, and you'll see that we have a common denominator. So multiply across, 5 times 3 is 15, then x. 15x over, you've got 3x, you've got x plus 4, and x minus 4. I'm going to go ahead and condense this. I know it's x plus 4 and x minus 4, alright? So I know x plus 4, x minus 4 creates x squared minus 16. Right? That's where it came from. So just for convenience sake, I'm going to write it that way. Alright, then you've got the 2 times the x plus 4 quantity, or minus 4 quantity, over, and now you've got the 3x again, and then you've got the x plus 4, x minus 4. So that creates again the x squared minus 16. And if you notice, doing this got us a common denominator, 3x times the quantity x squared minus 16. And now you just subtract across the top. You've got 15 minus 2 times the quantity x minus 4, all over 3x times the quantity x squared minus 16. Now, if you were told to simplify, which you were, you need to keep going. So you need to distribute the 2 in and combine like terms, which will exist. So you'll have 15 minus 2x, and then you have to distribute, right, something I should have mentioned as well. It's a negative 2. So negative 2 times x, which is negative 2x, and a negative 2 times negative 4, which is a positive 8 over. Now here you don't need to simplify this denominator. It's just standard that this is what you like your denominator to look like. So go ahead and do it. And then combine like terms. The 15 and the 8 combine. So you get negative 2x plus 23 over, and that is an x. Alright, so you've got 3x x squared minus 16. Alright. That marks the end of that section. The last part is coming up. I think we're going to do all of the rest of the problems all in the same part. Wow, we are almost done. Almost done. Hopefully you guys find this useful, and even though your school year is ending, if you're taking Algebra 3 next year and I'm teaching Algebra 3 next year, you can expect a lot more stuff like this, assuming I'm employed here next year.